This is for statistics. We are doing what we call as 12.2, a two-way ANOVA. So 12.1 is doing one-way ANOVA. 12.2 we do two-way ANOVA. ANOVA is short form for analysis of variance. So in order for us to have a two-way ANOVA, your data has to be partitioned into two factors. The partition into categories according to two factors means right now, like last time example, we use between a male and female and the state Iowa, Kansas, Iowa, Minnesota, and Illinois, let's say. So now you are partitioning your data into two types of categories, so we call it as two-way ANOVA. So every time when you do a two-way ANOVA, we have to do what we call as an interaction test. So how do we perform an interaction test? In order for us to perform an interaction test, in your interaction test has to be either, what's the meaning of interaction means both. So do we see if any two of these factors are effects, or if you have you find out there's no interaction, then you have to figure out if the one of those factors is an effect or not. So in order for us to do this two-way ANOVA, you might go up to 3 types of hypothesis testing. So there's quite a lot of work when you do a two-way ANOVA here. So when you perform a two-way ANOVA, so these are the 3 tests. There's up to 3 tests you have to do. So the first test is if you see there's an effect on the interaction between the row and the column. So if you say there is an interaction between the row and column, you stopped. But what happens if you do not have an effects on the interactions between row and column factors? Then you have to move on to the test number 2 to figure out if there's an effect on the row factors, and test number 3, effects on the column factors. So you can only move to you only do all these 3 two-way ANOVA if there is an there's no interaction. Sorry. So if you have no interaction, then you have to move it into if you have no interaction, you have to move on to the row and column. If you have an interaction, then you end right there. Okay, so the ending part here should not be there. So the ending part should be right over here. So this should be end right here. Okay, so I just want to point out to you that this is very important. So so if you have an interaction, you end right there. There you go. That means you do not need to do 2 more tests. But if there is no interaction, you have to continue to do the test, the second test and the third test. So so make sure you guys understand how do we figure out this interaction or no interaction. It's very important in this two-way ANOVA. So the requirement is asking us, there are 6 requirement check. Again, the first 2 are robust. The populations are approximately normal distribution, and the populations come from the same variance or same standard distribution. So again, these 2 requirements are robust. Then you left with 4. Simple random sample has the sample has to come with a simple random sample of quantitative data. It has to be independent of each other. It has to categorize in 2 ways, not 1 way, 2 ways, and then it has to be a balanced design. And what's the meaning of the balanced design? It means that if you have that means you have an equal amount of same number of sample size in these 2 factors. So that means that if you have picked 10 students that are from Iowa that is female, then I also have to pick 10 students that is from Iowa that is male, 10 students from Minnesota and male, 10 students that is from Iowa and female, and then 10 students from Wisconsin and male, and 10 from Wisconsin female. So that means that every single one here has to be what we call as balanced design. So you have to pick exactly the same amount for each case. So this is the last requirement for this case. So the procedure is, the first thing is to test if there is an interaction between the 2 factors. So the null hypothesis is a no interaction, and the alternative is there is an interaction between these 2 factors. And again, as usual, p-value is small, you reject the null hypothesis, then you are conclude that there is an interaction and you are done. So you are done in this case means you do not need to continue with the other steps. Then if your p-value is large, more than 5%, you fail to reject. That means there is no interaction. If you have no interaction, you have to go on to step 2 and step 3. So step 2 is you go a row factor. So how do we test a row factor? Is there is no effects from the row factor, and that is an effect on the row factor. So then you look at the p-value. If a p-value is small, that is an effect. If a p-value is too big, that is no effects. And then the test 3 is the column factor, so there is no effect on the column factor for now. Alternatively, there is an effect for column factors. The conclusion is if you have your p-value is smaller than your alpha, you have an effect. If a p-value is larger than alpha, you have no effect. So in this case, when you have a two-way ANOVA, once you got all these three procedure hypothesis testing is done, you have to make a final conclusion, and that final conclusion is combining conclusion from step 1, conclusion from step 2, and conclusion for step 3. That means that do we have an effect on both interaction, means both the factors, or just only the row factor, or just only the column factor. So that's the reason why that when you guys do a two-way ANOVA, it's quite a bit more work here. So how do we do two-way ANOVA in R? This is the word that we use, summary AOV x tilted A times B. So this is the two-way ANOVA R for this case. But before you do it, you have to figure out which one is your, how do you read this, get your data from the two-way ANOVA. So if your data is given to us in your file name, like bears and all these things, then again we use read table, but this time I don't use X, I don't use A, I use M, because we will use the letter A, B, and X here, so we have to use another letter. So sometimes your data file came out to be very nice. They're in category like male, female, male, female, male, female. They write the F and M and M and F, 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 M, M. Then you do not need to perform this. Then you just go straight to A equals to M comma sign, M money sign gender. But since if you sometimes the data they don't use MF, MF, they use 0, 1 or 1, 0, then you have to label this as this. So this is how you label your categories. So so the M equals to whatever we have, like male, gender. This is your category, your context. And then C, level C is 1, 2, 3. So this 1, 2, 3 is telling us that you got 3 levels. So it can be like Iowa, Minnesota, and Wisconsin. So if you have, so if you are lazy to read down Iowa, Wisconsin, and Minnesota, so you read that as 1 is Iowa, 2 is Minnesota, 3 is Wisconsin. Then you have to write this 1, 2, 3. And then this is called levels. And the labels in this case is IA, MN, and WI. So that means you have to tell the R that that every 1 is represent Iowa, every 2 is represent Minnesota, and every 3 is represent Wisconsin. So it's quite a bit more work in this case if your data is only consists of 1, 2, 3, or the levels. They don't give you the labels in this case. So this is how you label it. And sometimes the other one also has a label. So sometimes it's yes or no question. So you also have to label this, and yes or no, you got 2 levels, 1 and 2, and the label is yes or no. Make sure you put quotation marks around those, and make sure you have 2 closing parentheses here. And I just want to point out to you that your A is always categorical, and A goes to your row column, okay, your row factor. B is your column factor. It has to be categorical. X in this case is just very straightforward M label. This is a quantitative. So make sure that this is the X is quantitative. Your AB has to be categorical. And then the A is always the row and B is your column. And then you do your summary AOV. Now what happens if the data is given in a table form? So if a question given, then I suggest you to write the data in notepad form, which I will show it to you. And once you write in a notepad form, then you just label that as, then how do you label is A equals to M, your category, make sure that's row, B equals to M, your another category, and then C, X equals to M label, this is quantitative, and then you just use the summary AOV, X tilted A times B. So so writing the data in Notepad might be a bit more work here, but these are the few ways that I can tell you to do. Okay, and yes, doing ANOVA, two-way ANOVA is a bit more work than performing one-way ANOVA. So once you do your summary AOV X tilted A, this is what your result looks like. So if you see A, this is your row factor, your degree of freedom, this is your test statistic, this is your p-value. B column is 1. This is the degree of freedom. This is the test statistic. This is the p-value. And then you see the A dot B. The two A dot B in this case is an interaction, mean both. And that is the F test statistic. They're all F here. This is your F distribution. And your p-value is right here. So what happened is you always look at the A to B first, the interaction first. If this p-value is small, you stop. That means that there is an interaction between those two. But if your p-value is too big, that means there is no interaction, you proceed to 2 and 3. And once you look at this, if you use a 5%, then we find out that this number is greater than 5%, so your row has no effects. And this number is less than 5%, then your column, in this case, will have an effect. So that means that there is no effect on the row, there is no effect on both, but there is an effect on the column. So if your R results came out like this, sometimes they have a little star on it. It's just telling us that, guess what? We have an effect on this one. So, so I wanted to point out to you that it's quite a bit more work to do in your two-way ANOVA, where the results are very short like this, and you have to be able to read these results.